With much of what we learned in the Rust programming book, chapters 1 through 6, we now have enough knowledge to build a simple command line game. Let's build something that's simple and resembles a game, Pitfall, and we can run it on the command line. Hi, I'm Ricky, and welcome to the Dev Method. Alright, so there's so much to learn and so much to review, so I put together a little game for us so that we could take a look at all the different things we learned in chapters 1 through 6 of the Rust programming book. So a couple of things, I'll list them out here. There's variables and mutability, there's data types, there's loops, there's structs and enums, there's ownership and borrowing in Rust, there's functions, and then there's the match statement. So this game was created by me, and it's not part of the Rust programming book, but I thought it'd be a real good time to take a break and just review a lot of what we've gone through so far. Now, in order to make our lives easier, I thought we'd pull in a little extension for VS Code so that we could iterate through experimentation fairly rapidly. So we're going to use something called the Rust Analyzer. This will give us some auto-completion, and every time we save, it'll recheck our program and see maybe what's not correct or what doesn't pass the compiler check. So if you go to the marketplace and type in Rust, this is what you'll find. Now, I skipped the first one, and I went straight to just the Rust Analyzer. Just install it from here, give it a couple seconds, and you'll be ready to go. So another thing we should talk about real quick is just terminology, so we get an idea and we'll be on the same page as to what I'm talking about as we're programming. So we have a board that has a course, and the course has many places. Each place can either be an obstacle or a free space. Each obstacle has a penalty, and if a player lands on that obstacle, they'll go back so many places of whatever that penalty is. Each player's turn will consist of a roll and their current place on the board. And after each turn, we'll print out the board. And the player is going to take as many turns as necessary until they win the game. All right, so let's get to it. I want to just call out here line 20 really quick before we jump into all the extra code. We'll show an overview in a moment. But the first part here is we want to roll the dice. Then we want to find the next place in the course for the player. And then we want to move the player to that next space or that place in the course. And then we'll print out the board. So real quick on the left-hand side, I brought up the outline just so you guys get an idea of how this is structured. But we have our main function there, and I'm keeping that toward the top so that we can easily change or modify the code. But then I have a bunch of other functions below it. I have a struct, I have a couple enums here, next place and space. And then a couple more functions to help us out. So let's walk through the setup real quick. The first thing we're doing here on line 11 of main, which is our first line of code that runs, that is going to be making the course. And what this is it's a very simple function. And again, this is how we declare our function. We have fn, space, and then a name for it. The idea here is that we give it a length, and that's as big as we want the board, or the course. This is as big as we want the course. So that course is going to be a vector of spaces. So real quick, let's just go to spaces. So again, here's a space. It could be either an obstacle or a free space. And the obstacle is going to take here what I'm referring to as the penalty. And that type right now is just usize. So right now, the way I'm doing this, I'm using a while loop. And this while loop takes here just checking to see where we are in the index. We don't want to go outside the bounds of what the size is. And we're putting everything in what is called a let mutable course. And that is what gives us this push. So what we do is we iterate through. We're getting just trying to see whether a space is going to be either an obstacle or a free space. So I'm generating something random here, and I'm just getting within a range of 0 and 1. And by that, we're going to just know whether it's a free space or an obstacle. So that was my way of determining the two. And then yet again, I have hard-coded here a penalty of either 2 or 3. So this is an exclusive range, but same kind of code. And we're getting a usize because we need to add this colon space and then the type here, because this RAN has many generators for different types of ranges. And so in this case, we want to get the usize, and we got that penalty, and then we push it on to the course. So we do either a free space or we do a penalty, and then we just increase the I and we move on. And at the very end, we return course. So that's what the first line of code does, pretty simple. And then we need some state or something that helps us understand where the player is in their journey through playing this game. And so right now we have a place which is going to be our index into our course. And we're just starting at 0. That's just the idea. But we also don't necessarily want like the player to start on the first space of the course. So that's why I have this first role. And then we're always going to be setting that to false when we're playing the game. But at least the first time we run through the code, we have a slightly different outcome because it is the first role. So we're not going to go outside the bounds of the vector. Now, the next thing I want to do here, just so that it's really simple, I have here on line 17, I'm just going to print the board. So I'll give it the course length, which is supposed to be like where the person is inside this course. And then I'll give it the course itself. So notice here, we actually are passing in on line 17 a reference to course because we don't want to take complete ownership of it because course is going to be used elsewhere in here too. Let's see. Yeah, it's used down a little bit further in the application. So we don't want to take ownership of it. We want it to keep living. Otherwise, we'd have to have like make display also return then the course again so that we keep ownership. So right now we have ownership and then we're letting this function borrow course. So that's the idea. Let's take now a look at what make display or make board display actually is. All right, so we have on line 49 the definition of the function, and you can see that there's a vector of spaces, and then it's actually going to return a vector of strings. So that's what the course is, the vector of spaces, and we're borrowing that. And then we're actually going to give that string to the calling function, or the vector of strings. So we're just trying to represent each of the places as some sort of like something we can look at and see. So here it is, board, okay? And then it's got we're doing some sort of enumeration on this. So we can actually create an iterator and then enumerate through it so we get each of the indexes in it. And that's actually really helpful for this next part, 56. And we're just trying to see if that is the same place. So if we're on that place, we're going to do a plus next to the index so that we know where we are on the board. Otherwise, we're going to push the item. And in this case, it's going to be a match. We're going to get that item here. And we're either matching on an obstacle or matching on a free space. So let me print this out for you guys just so you guys get an idea. I just wanted you to get a quick idea of where we are in the code so far and what the application actually looks like. All right, so ignore the warnings for now. We'll come back to those, but I just wanted to show you that this is the part I'm talking about where all these fire emojis are. And how did these come to be, and how did we get to this point? So that's actually the course got made. So that course there we're going to use for when the player actually starts playing the game. Because right now it's still waiting for the game to play. That's what we're waiting for right now with this blinking cursor. But then the fire are the obstacles, and we don't know what the penalties are until we get to them. And then the underscores are just like the free spaces. So that's just the idea of what I wanted to show you guys so you have an idea of what the code is actually doing. Now, because we're just printing out string representations and we want to hide what the penalty is, when we're matching on obstacle, that's where we put in this underscore instead of something like value or something like that. We don't care about what the value actually is. Like maybe we could put a little number next to it so we know that it's a penalty of 2 or 3 or something like that. So we have these two string representations of what the obstacle is, and I just want to show you here how they're declared. They're declared as constants, and that means that the values will not change as the program is running. So here they are on lines 5 and 6. So the obstacle I'm just representing as a fire emoji, and then the free space I'm representing as an underscore. All right, so let's talk about the next part, which is rolling the dice. So I have a couple different ways we can roll the dice in the application, but I just want to give you guys an idea of the concept, is that we have 2 dice. We have 2 6-sided dice, and that's just how I programmed it. So we have roll 2 dice, and I'm giving it 2 different ranges, and then when that's happening, it's generating 2 different numbers and returning that actually as a tuple. And then we're taking that tuple, putting it into an array. We're going to iterate over it. Now this can be done because remember arrays are different than vectors where arrays have to have their size known at compile time. And since it's always 2, we know the size at compile time. And we're using this iterator because we can't actually iterate over tuples. The arrays have to be the same type for every element in the array. So that's why we can use an iterator. And then right now I'm using this special built-in function sum. So I'm getting a sum of all the numbers in this iterator. And I'm using that as like the roll. Like if I roll a 2 on one dice and a 4 on the other, now I have a roll of 6. So let's look at the implementation. So here I have on line 106, roll 2 dice. And what it's meant to do is block the user or block the standard input and wait for user feedback before we continue in the application. So to do that, we have first our println or print line. We're just printing a line with 2 emojis saying we're rolling 2 dice so that we know which one it is. And then we're taking from standard in, reading a line. Now, since I don't care what standard in actually is, I'm not doing any validation on that. They can type in whatever message they want. I'm just putting that into a new string, buffering it into a new string. And then this expect is just saying if something fails, like we can't read the string or something like that, then we failed to read the line. So I haven't run into an issue quite like this yet, but you do want to think about where your program can actually fail. And I knew that because the return type on line 110 actually shows a result. And so that's very common in Rust, is that we have this struct result where the first thing is some sort of success, like a value that we're getting. So in this case, we're getting a U size on a success. Otherwise, we're getting an error. And the way I'm handling this result is expect. And expect, actually, we don't need to get anything from its return type, so that's why we're not assigning it anywhere in this function. But what I do is I actually call this generate random from the ranges that I gave it on the 2 different dice. And then I return them as tuples. So there's that return type on line 106, just showing it after the dash greater than, which looks like a little arrow. So that's how I get the roll, and then I put it into a turn, which I call the player turn. I give it the roll, and then I give it a current place, which is just the place that we started way up here, right at the top, which is always 0 to start us off. Now looking at line 117, this is where I defined the struct player turn. And I have a roll, which is a U size, and then I have the current place, which is a U size. Let's go back to the usage of it real quick. I decided to keep this constructor for this struct really easy. And I'm using this shorthand here where roll is what it's called, but I also have a variable called roll. And putting that value into the field is really easy in that way. It's very similar if I just did something like this. That is the same thing. But now with current place, we don't necessarily call it current place, but I guess I could. But I did this as the example, and that's where you have the colon space and then place. That's how you assign it that way. And then I have the turn, and then I'm going to print that out on the command line. So let's walk through what that's like, and let's see the rest of the output of the application. All right, so I printed out the board. It's waiting for my dice roll. So right now, I'm just pressing enter or return, because once it finds the new line, then it actually moves on and rolls the dice. All right, so it rolls the dice, and here's that player roll. So I rolled 7. Right now, we're not printing which number came from which dice, but that's fine for now. My current place is 0, and it actually says that a space, it's a free space, and I'm denoting that actually by this green check. So let's move through the rest of the output so you get an idea of what the end goal is here. So that's not an obstacle. We have here I have like a target here. That's just saying I'm printing out the board again or printing out the course. So it looks like I rolled a 7. So I would have done 1, 2, 3, 4, 5, 6, and then 7, which is in that vector, it's an index of 6. And it says it's a free space. So if I look back here at the original board or the original course that was printed out before we did our first turn, yeah, it shows that that is a free space. So that's why it came out this way. Now, if I roll again and press enter, got a 8. So we went even further in the board. So now we're at index 14. So that's actually good. So let's keep going until we get one of the obstacles. Free space again. Here's an obstacle. Okay. So I rolled an 8. I was previously here. So if I went 1, 2, 3, 4, 5, 6, 7, 8, that's where I ran into the obstacle. And the penalty is to go back 2 spaces. Could have been 3, but we found out that this one was 2. So it'll go back here. And that's actually what I see down here as well. So I'm at index 26. And we're going to keep going until we win the game. That's the idea. All right, so the next part here is this find next place. What I give it here is the player's turn. I give it a course length, which was defined also as a constant in our application, and then whether or not it's the first roll. So the return type here is actually next place. So let's take a look at this real quick. So on line 122, next place, we either have just a place with the index or the, wherever it is, or it's the game is won, and then we should stop playing the game. So just looking really quickly at the application, I calculate into a local variable the next place, assuming that the roll and the current place end up being something that's of value to us. But if we're outside the course, because we have the course length here, that's where we're saying return that enum variant as game 1. And then if we do an if else, so if we're less than the length of the course and we're on the first roll, we want to take that turn and then minus it by 1. And then on line 140, we have here just the next place. So if it's not the first roll, every other time, just put it in next place. And since we're doing a match, we have here matching on if the game is won. We're going to print out that we're finished with the game and that we're going to break on game. Now, I didn't have to label it quite like this, but let's review the loop here. You can actually label your loops. So you do this opening single quote and then some sort of name colon and then space and then loop. And then here I am breaking on game. That's the idea. I could have also returned a value or something like that, but we're not going to do that right now, just for the simple use case of writing this game. But now the next part here is we're going to move player to the next place. So let's take a look at that implementation. The first thing we're going to do is pass in, and again, we're borrowing the course, right? Because we have this reference here. We're not going to mutate it or anything, so it's not a mutable reference. We're just saying we're going to borrow it for a moment because we want to get something out of it. And so we're borrowing course, and then we also give it what the next place should be. So we get the space with the next place. Now this is a vector, right? So it is possible to go outside the vector, and we want to protect against that. So that's where I use this .get. I could have used something like this, where I just use the square brackets, and that's okay too. Because if we think about this, the .get doesn't return just the item in that array or that element. It's actually something called an option. So if it's an option, that means the value may be there or may not be there. And that is because we go outside the bounds of the vector. So it might be too high. It might be higher than the length. So if the length was 10 and we gave it 11, that's when we get none, the option type none. So just to review that here, we're actually going to match on space. And we have actually 3 different cases we want to match for. We could do more, but right now it's just the 3. So the very bottom one is probably the easiest one to understand. That's just saying if we didn't find anything, just give it back the same place that we had before. So whatever was passed in, we're going to pass that in. And the whole point of this move player to the next space is that we want to figure out if they need to go advance further or if they need to go backwards because they had actually hit an obstacle. So that's what this first one is doing here. Let's check and see if we have the obstacle. So if we have the obstacle, we're going to print that out. We're going to say that this was an obstacle, and we're going to use that constant again here, the obstacle display, so we know that that string looks like a fire. And then we're going to say what the penalty is here, so go back so many spaces. And then I have another function that I wrote here that is I hit an obstacle, so give me the next place, but with the penalty. So this is a little trick here. Well, maybe not a trick, but some sort of tip that you could use when you're trying to figure this stuff out with the borrowing and if you have mutability or not. So in this case, what I'm saying is we have some sort of space. And if it's an obstacle, that's on this branch. Now, we don't care what the penalty is, so that's why it's v. It's like a variable penalty. It could be 0, 1, or something like that. Right now it could be either 2 or 3, but this function doesn't care about that. All it cares about is telling you if it hit an obstacle and what the penalty is, so you have to go so many back. So in this case, what we're going to do is return the value from that function. Now with the free space, we're just going to say like, okay, it's okay to move on, no worries. And then we have here print out, didn't run into an obstacle. So let's look at hit obstacle. What does that actually do? This one's pretty simple as well, but we're comparing the values, and that's the idea. So we have the penalty, and we passed it in this value. Here, we're dereferencing that value because v is actually a reference to a usize. So now we want the value that's in there. So we're like creating a copy, passing it in here. See, we have penalty. Yeah, so then we get the temporary value. We just want to match that against 0. So if it is equal to 0, just give it the temporary value. That's totally fine. If it's less than 0, then return 0. That way we don't go below the bounds of the array or the vector. And then if it's greater, just go ahead and give us that value as well. So this is where we're protecting against going outside the board and too far down. And then this is where we're actually saying just move on if it's the same spot, or if it, if you move 2 places up and then you have to move 2 places back because of the obstacle. That's what the equals is for. So now that we moved our player and we're returning that value of that place, we actually want to keep that. And again, that's our mutable part. So that's mutable up here. That's our state for our application. We're just keeping it. And that's how we know where we're supposed to go next. Then I make use of the same make board display. It's the same function that we ran earlier. And we're going to just print out where we are. And now that we actually have an index into that array, which is our place, that's how we can get an accurate visual representation of where we are. And I get it, and I call it snapshot because it's just like just this turn. And then I pass that snapshot in here. And there we go. Now you might be wondering what is with this colon and then question mark. So if you take a look here, the vector on its own doesn't conform to display. But if we put in the colon and question mark, it does conform to like debug. So we can get like a default, like a debug string printed on the command line. So that's just our shorthand for doing that. Now here we are at the end of the turn, and we're saying our first roll is always false because after that first iteration, now we know it's no longer the first turn anymore. All right, so let's run the application one more time and let's see if everything works just fine. Cargo run. All right, so we're going with 2 dice. All right, so the roll was 5, the current place is 0, and that was not a, you can see here, it wasn't an obstacle, so we just keep going. And I'm just going to keep going a couple more turns. Yeah, so there we go. So now the player rolled 5, the current place was 27, see right here? So then 1, 2, 3, 4, and then 5 would have been the end. If they would have gotten 6, same thing would have happened, they would have finished and they win. They don't have to exactly get 5, but there we go. Then it worked. So real quick, let's say instead of 2 dice, we wanted to just roll 1 dice. So how could we refactor our application? Well, here we have roll 2 dice, and just above its implementation, I have something that is currently not being used in the application, so that's why it has that green squiggly underneath it. It's saying that it's like dead code. It's just a simple warning, but it does the same thing. It rolls the dice, but it only gives back 1. So let's go back and just do 1 dice and see how long it takes us to get through that example. All right, so it's telling us here, and instead of what we had there, now I know it's only one thing and we're getting the sum of one thing, but I wanted to minimize how much we're actually changing in our application. So there we go. Pretty cool. So let me revert those changes. Now the other thing we could do here too is that the course length right now is set at 32, and since that's a constant and I'm shipping it with the application, I could just say it's 8. So we could technically win the game in 1 roll. So let's just try it out, see how that works. cargo run. All right, here we go. First roll, 6. Okay, we're over halfway through the course. And it was a space, so we didn't have to any penalties. All right, cool, we won. Now let's say the course length, we'll bump that back up to, let's say 12. But instead of our obstacles looking like fire, let's put something else like the mind blown emoji. So let's try that. So let's run it again. All right, so here's the new obstacles and what they look like. Rolling 2 dice again. Oop, there it is. Space is obstacle, go back 3 spaces. All right, cool. So we rolled a 7. 1, 2, 3, 4, 5, 6, 7. That was the obstacle. We go back 2 spaces, so we're actually, or 3 spaces, so we're actually right here. Pretty cool, works. Thanks for watching. If you guys have any questions, just leave them in the comments below. I'll do my best to answer them. Otherwise, have a good one. See you again.